Okay, guys, moving swiftly along with this project. Now that in other videos we've looked at getting PLC data up to through an OPC UART protocol. We're going through a Node-RED platform and then up onto the cloud to IBM. We're now going to look at just another system, the left-hand side, where we start talking about an embedded system and how we can get that data up also onto the cloud, and then how we can basically link both devices together. Now, really what I'm going to do is I'm going to spend some time going through some of the code and libraries that would be used on the embedded side of the project. Okay, now there's three source codes, so I'm going to do three separate videos to show different elements of what could be used for your project, and then it would be up to the person to bring those together. So initially with my project and in these tutorials, I'm using a BME280 sensor, okay, which can measure a couple of things. It can measure temperature, humidity, altitude, and pressure for me. So I can get four metrics, four sensor readings from this particular device. And of course, you can add multiple sensors and build up the project as much as possible. But this will give me enough data to kind of prove the unified architecture that we're looking for. So this is all done in the ESP32 controller. It's connected to it, and this code is developed on the Arduino IDE, so the local version of the software, not the cloud package. The online cloud package is the local version, and we're using that in developing our code with that. So what I'm going to do with each section of code, try and talk through it, try and explain a little bit what's going on, and kind of explain it at a high level. We're not going too low into it, but just to try and give an appreciation on what some of the libraries are doing and then what's happening in each section of the code. Okay, so I'm going to stick in or crack on with this. This is the source code for the BME280 sensor. Okay, using a library from DFRobot. Okay, this is where we got the sensor from, and they've developed some code to help us really use the sensor in a very easy to use way. So with all Arduino sketches, they will follow a similar approach. You've got your declarations at the top, you've got your setup function in the middle, and then you've got your void loop. Okay, and in each of the three videos, we're going to look at three different sets of code, and if you're joining them all together, all the void setup code has to go into one void setup function. Okay, one setup function. Void just means it's not returning anything from the function. So yeah, that's how you kind of bring them together. But anyway, let's just talk through this first. So the very first thing we have is we're asked to include two libraries. Okay, now some of these libraries you can get from the Arduino library installer itself. Some of them are specialized, user developed, user designed function or libraries that you'd have to upload to use this. So DFRobot will give you a zip file, a library that you can import into your Arduino IDE software. And then basically we have a statement there to start to call the library that we're using, because there's functions inside, there's code written in these libraries that allow us to use functions just to make our life easier when we're coding. So this is directly relevant to the sensor. The wire.h is the I2C, so the I2C protocol that the sensor is connected along. So you'll see if you're connecting up the sensor and you're wiring it into your microcontroller, you will wire it along the I2C connections. So that's just saying we're using both those libraries. Then the other thing, we're going to do some declarations here. So we're declaring that we're using a particular sensor. So DFRobot with their libraries probably have multiple sensors and stuff that we're going to use. So it's just declaring that this is the type of sensor we're using. Then what it does is it sets the I2C address bus. So it's saying we're using the address 77, which needs to match the chip that you're using. So the sensor that you have will be on a printed circuit board, and we need to know that we're using the address 77. That's usually the default one. So with the ESP32, you can use two, I believe it's two anyway, two addresses. So if you could have two different sensors communicating along the address bus on address 77 and 76. So you just need to make sure that matches with your chip. Then we're defining the C pressure level, It's kind of a standard unit for the area for the calculation later on. So some declarations at the start. Then we have to initialize or create a function that will tell us the status of the sensor. It gives us a little bit of diagnostics. Basically, when you turn on the microcontroller to start, it will check to see, is everything okay with the sensor? Is there some sort of error? Kind of find the device, maybe it's not connected up correctly or things like that. It gives you a little bit of fault finding. Okay, so again, this is a standard function that's given to us to check that sensor. And that's all it's doing. It's just we declared this function earlier in our code, and then you'll see we go to use, see this eStatus, we then call it later. Where is it? This is it here. We start to call essentially the function to see. Oh, sorry, there it is there. Sorry, that's the one there. So that's the name of the function, and that's the name of the function, and it's going to call the correct error from it if everything is okay or if it's not okay. So we're just setting that up initially, and then we say go ahead and run that function when we're in our setup. So that's the function. Again, it's designed. Sorry about some of that background noise, just a compressor running. So yeah, so we've got a function there, and we're able to get some diagnostics from it, and that's where it's being called later on. So that's all our declarations, all at the start. Any libraries you're going to use, any variables or stuff you need to set up, and then any functions that you're going to reuse within your code need to be set there. In your setup function, this is the code that will run once before the system goes ahead and runs the main bit of code, your constant loop. So this just runs once. So what we have is we do our serial begin and we set our baud rate, and that's for our serial monitor to allow us to get some feedback anytime we do a serial.print. That will print to this monitor, and we can get some diagnostics from what's happening. So as soon as we turn on the embedded system, the ESP, it sets up a serial port and the baud rate. It sets up our sensor, okay, and then basically it checks the status, okay, and when it goes through that, it will print the message that if it gets an error, so it'll print one of these messages here to say either it's connected okay or it's not. So once that goes through that, then it will stay within that loop. It's a while loop, so it'll stay in there until it gets some sort of error or some sort of success, and then we can say, right, we're happy enough, the sensor is connected properly, and it will go into our main loop. So it can stay in this while loop here until the device is fully properly set up. So that's just all in our setup function. Then when we go into our main loop, quite simply, it repeats this loop every 1 second, okay? And what it does is it actually creates a local variable, okay? We could have created this up here if we wanted to. And then it uses the function, the libraries that we've installed earlier, it uses a function there to get the temperature. So once it calls that, it just pops the value of the temperature locally into that variable. Same when it does the pressure, pops it into there. Same when it does altitude and humidity. It just calls those functions from the library that we've installed earlier, and then it stores it into those variables there. We've declared them locally within the code. We could have declared them globally at the start here if you wanted to. And we've just used, depending on the side, or if you're storing decimal points or things like that, we've got different data types that's being stored. Then all it does is it prints that value to the serial monitor so that we actually can see what our current temperature, pressure, altitude, humidity is. So you can see all those local variables that we've stored the data. There's the names of them. We're just printing that to the serial monitor, and then we're waiting a second, and then we're updating the values. So really that's a very quick check. You could delay that to maybe every 10 seconds, every 30 seconds, whatever it is. But at least at the start, if you do it every 1 second, and then maybe you blow on the sensor, kind of rub it to heat it up or things like that, you would see the values changing, and then you've got some success. So that's a quick overview of some of the source code at a high level, not delving into it too much. So if you've got an appreciation of some embedded C coding or some C++ coding, that should make a bit of sense to you. and that allows us to integrate the BME sensor with the ESP32.